let's go in and pull down a database. Just for laughs, I might pull down a database from my 143 class. Just to shake things up a little bit. And I'm going to go open it up and convert this to 2010, so it's an older database. Maybe.
While you're opening that, you had mentioned briefly in class with the car maintenance intersecting table, not to do a double primary key. And so that would mean that it would allow for many cars to have many oil changes, but only once individually. Is that what the result of that was? That only a car could have a single oil change as a result of that?
Yes, let's talk that through. And I'm not having luck converting this. I'm not doing something right, obviously. So we'll go back to a different database. All right. The question was, is in the auto database. There's going to be a car table, and there's going to be a services table. The car table contains a list of cars, right? Obviously, the service table contains a list of services. These are the services that we're interested in tracking, all right? We don't want to have something that the car table has in it a date for the oil change, a date for the tire rotations, and all that, because we might change the particular services we're interested in tracking. All right. Maybe we were not interested in tracking the last time that the air conditioning was flushed or whatever, and then we decide we do want to track that. So remember, it's never a good idea, or how can I say this? It is always better if you don't have to change the structure of the database. If you're simply adding data to a table, that's easy and that's straightforward. Whereas making a structural change, and what do I mean by a structural change? Adding a table, adding a relationship, even adding a column. Those kind of changes, all right, are more expensive because anything that uses that table then is apt to have to need to be changed. So therefore, we wouldn't want to have in here last oil change date, last tire rotation, and so on, because if we decide to track another service, we'd have to add that to the list. So what we're going to do is we're going to have a car table that contains all the cars, a service table that contains all the services. What's the relationship between them? Well, it's obviously a many-to-many, right? Because one car can have many services performed, and a given service can be performed on many cars. Okay, so it's a many-to-many. Now, what I said was this. Oftentimes, when you do a many-to-many relationship, you make a car service table and primary key of this table can become the concatenation of these two keys. All right? Let's think that through, though, in this case. What that's saying is the combination of the car ID and service ID would have to be unique. All right? That sort of does what we want, but it's probably not good enough. This would allow us to put in one car having many different services, right? But we could not put in that a car had 2 oil changes, right? Because if my car ID was 123 and the service ID was 1 for oil change, this being the primary key would mean that we could have only one row in that table that had a car ID of 123 and a service ID of 1. All right? So if it had an oil change on May 1st, we couldn't enter in that it had an oil change of today, 10/18. All right? Because that would create a duplication here. All right? Thank you. But it's great when I'm talking so loud that they go and close the door for me. All right? Usually it's the other way around. I feel a small measure of revenge for all the people that stand outside my classroom and talk very loud if people are annoyed by my lecture in here, doing what I'm supposed to be doing in here, doing my job, and it annoys them. So I feel good. Yay. All right. You see what I'm saying now? This combination would have to be unique, and therefore I could only put in one oil change for a car. Now, okay, is that bad? Yeah, I think it probably is bad, right? Because I may want to, I may want to track how often a car has had its oil change, and I may not just be interested in the last oil change. I may want to know, when the oil change was before that. Maybe if it went a long time for the last oil change, I'll spend less time before the next one or something. I don't know. But the way the project is defined, you want to keep track of all of them. You want to keep track of the history of all of them. So what do? How do you fix this problem? This can't be the primary key, obviously. So what do we do instead?
Make them foreign keys.
Okay. Well, there'll be foreign keys. There'll be foreign keys anyhow. All right. So yeah, there'll be foreign keys. Even if it was the primary key, there'd be foreign keys.
But each service then has its own identification number. Each car service combo has its own identification number.
Right. That's the other thing that we could do, is would make these foreign keys not primary keys and create a car service ID. And that would be the primary key. And that would simply be an auto number. So the very first service that we perform on any car would have an ID of 1, the next would have an ID of 2, and so on. So that would be unique, and these would not be part of the primary key. All right? So that's one way to handle it. Another way to handle it, by the way, would be to simply keep this a primary key, but add a date to the primary key. Right? Because a car is not going to have 2 oil changes on the same day. All right? That's kind of an absurd situation.
So still have the double primary key, but make a date.
Make a triple primary key. So
Oh,
another option would be
Ah.
car ID, service ID, and date. Yes?
I can think of a way it would have 2 oil if they messed up the first one.
Is that important to track then? I guess we'd have to ask. Or, I guess we could get into a philosophical discussion and say, if the first one was messed up, then it really wasn't an oil change at all. In which case it only had 1 on that day. At any rate, this would be an acceptable solution, this would be an acceptable solution. Now, my own personal bias is to make all auto number keys. So that probably would be the approach I would take. All right. Now, that begs the question, all right, or Amanda doesn't, well, how can I put this? There are situations where this isn't a good solution, or this is only part of the solution. Let's say, for example, and again, just in case someone wants to concoct unusual sort of scenario, let's assume we're talking about one semester at a time. Students enrolled in a class, all right? That's a little bit different of a one-to-many or a many-to-many relationship, right? Because we have a student, we have a class, and again, if we're talking about a single semester at a time, a student class table should not have the same student-class combination in there twice, right? That's different than oil changes. A car can have many oil changes. A student is not enrolled in the same class more than once, in which case this would be an acceptable solution because this combination is unique, all right, and we want to enforce that. Now, can we go and can we make an auto number key in here anyhow? Just because, as I said before, I'm biased towards auto number keys. And the answer is yes. However, we should then go and make this a unique index. Right? Remember, anything that's a candidate key should be made into a unique index. What's a candidate key? A candidate key is something that could be the primary key, but we've chosen not to make it the primary key. You know, probably the classic example of that is an employee number or social security number in an employee table. All right? Either of those could be the primary key to a table, but we pick one. We probably pick employee number. Well, what do we do with social security number then? If we simply make it as an attribute on the table, we would have the potential of entering two people with the same social security number, and that wouldn't be correct. So therefore, we make it a unique index. So, to summarize, all right, to summarize, you can add a surrogate key, these are called surrogate keys, an auto number or a generated key, to implement a many-to-many relationship, all right, in a database. But you do need to be aware whether that many-to-many relationship allows multiples or not. So, for example, the student class 1 does not allow multiples. Given one semester, a student's only enrolled in one class once. So therefore, you either make it the primary key, that will enforce the unique constraint, or you use a surrogate key and put a unique index. Now, in the case of this one, where multiples of this combination are allowable, all right, you can make a surrogate key. If you do not make a surrogate key, you need to add something to that primary key, such as day, to make it unique. All right? So, did that kind of clarify where we're coming from there? Yeah. I wish there was a more encompassing term or a more descriptive term for one-to-one, for the many-to-many relationships, because there really are sort of two different kinds. The one is where the combination of the two tables are unique, and then the other is where the combination of the two tables are not unique, because you definitely handle those a little bit differently. It's a little different than a one-to-many relationship, because pretty much all one-to-many relationships you handle the identical same way. let's pull down a database. Used in past terms. And let's go and essentially repeat the same thing that we've done last time, but just so that we're clear on things such as how to make that database connection object and so forth. So, I have a database that's similar to the database that I had previously, maybe with a few extra rows in it, definitely a few extra tables. The old Northwood sample database that has students, enrollment, section, course, term, location, faculty, and faculty rank. So we have a few more tables to play with in this example. So let's go and let's make an application that will access and read this database. So I'm going to go in and open up Visual Studio. And create my application. I didn't want to do that. So I'll delete it, and I want to start with an empty one. Pick an empty website. And please change the name of your website from website 1 and all that. Don't just take the defaults. Go and name things properly. That goes to variables, controls, anything like that. Alright. Now again, if you open up or if you create a empty website, all it gives you is a web config file. Alright. With a database, we want to go and we want to create an app data folder to put our database in. In this case, our access database. So I'm going to right mouse here, and I'm not even in Visual Studio or anything, I'm just in Windows Explorer. And I'll create a new folder, and we'll call it app data.
Does the capitalization matter on the...
No, I don't think it does. Windows in general is not case sensitive. I just noticed that when they created it, it capitalized it, so I just did it to be consistent. If you remember last time, I don't think I capitalized it, and everything just worked okay. All right, then I drag my database into that app data folder. So now, again, everything is underneath the application, right? Your database and your web config file and all that. So what you'll do is you'll zip up that folder to me and you'll send it to me, and you'll have everything for that. Now, what is the reason for creating that app data folder? Does anyone recall that? We wouldn't absolutely have to, but I said it was a good idea.
Keep it hidden.
Yeah, to keep it hidden. There's special security applied to the app data folder, which would prevent or make it harder for someone to be accessing it. So I could put it in the application folder, all right, but then that security wouldn't be applied. Now, the offshoot of that is don't put anything else in the app data folder, stuff that you want the web server to serve to your clients. For example, don't put images in there, all right? Because if you put images in there, the web server is going to look and say, oh, app data folder, this must be top secret stuff that we want to apply special security to, and therefore, if a user requests a page that has an image that's in that folder, the image won't get delivered. All right, so I can go in here and I can hit refresh. All right, and now I have my app data folder and I have my folder underneath there. So let's create the page to pull up everything from the faculty table. So I'll go here, faculty, new, file. That's one thing that I don't like about Visual Studio is it's very context specific. In other words, I had, I think, that selected. So therefore, when I went to File, New, File, I get a whole bunch of goofy little options here that weren't what I expected to see. If instead I've highlighted the application folder and I do File, New, File, there I get the stuff that I was expecting to see. So if you ever get a list of things, like when you do File, New, File, or in other situations, if things come up different than what you expect, it could be that you have something, the wrong thing selected. All right, and therefore, it's nice because it's trying to anticipate what you want to do and give you your options based on where you're located. But again, if you're not really aware of that, it can be confusing. All right, so I'm going to create a web form. All right, and I'm going to click Add. So I now have my web form. So I'm going to use the GUI to create this, but then we'll go back and we'll look at it in the code view. That's one thing that I really would like to stress is the importance of at least, on some level understanding the code view. To be sure, on occasion there's attributes that I see in the code view that are puzzling and I'm not 100% sure of what they do. But you should at least be somewhat conversant with how these objects look in the code view so that you have an idea. Some things which are tough to correct in the GUI view are a piece of cake to correct in the code view. All right. Some things which aren't very apparent that are problems in the GUI view are real easy to see exactly what's going on in the code view. All right. So as you remember, all of our database interactivity, most of it anyhow, it's wrong to say all, but most of our database interactivity is going to contain two pieces that work together. There's going to be a visual component and there's going to be a data component. All right? And those things are going to be bound together. All right? And that's good because the alternatives, and if you worked in other languages, if you've done any PHP coding or if you did any old school ASP coding, sometimes those things all get just globbed together in a giant mess of code. And that's very tough to debug, and any changes in one thing really has a big impact on everything. Whereas this, again, the philosophy is having everything as a nice little component that does its job, and just making sure the components talk to each other and work well together. All right? So we're always going to have, all right, or most always going to have, a visual component that's going to display the data, all right, that's going to show the data, the user interface component. And we're also going to have a data component that actually does sort of the database interaction and grabs the data from the database and so on. Visual component and data source. So the first thing that we're going to do is we're going to create the visual component. All right? I guess we could do this in either order. It doesn't matter. You just have to do them both, and and then you have to bind them together. So the first one that we're going to do, the first visual component that we're going to do is a grid view. So I'll bring that over. And again, I can use the auto formatting to get the look that we want. All right. There's some other attributes of it that we can control. We can edit this. We'll see some of these things going forward. We can edit the columns and all that. We'll take a look at that in a bit. All right. So that's our visual component. And again, as was asked last time in class, do you have to use that auto format? No, you can apply your own CSS styles, and you can go in, and you know the ID of this. All right. You know the ID of it. Grid view 1. I'll change it to grid view faculty, because this is what it's going to hold. All right. We know the ID, so we can go in and we can write CSS code to access it. Remember, you can always go in and write CSS code to access it if you know the HTML tag that is going to be generated, if you know the ID that's going to be used, and if you know the class name. Those are your hooks from your CSS to your, or from your HTML to your CSS that you can go and you can grab and you can attach styles based on those. All right, our data component. Let's grab our SQL data source. And again, this is a SQL data source even though this is an Access database. Don't mistake SQL data source as meaning SQL Server database. Okay?
Problem I ran into.
Yeah. Access data source actually relates to, I believe, older versions of the Access database. But even with an Access database, you can use a SQL data source. So I'm going to go drag it over, put it on the page, and then I'm going to click to configure the data source. Now, the first thing is we want to create a new connection to the database. All right? When we create a SQL data source, let me rephrase that. When we create our first SQL data source within an application, we're actually going to create two things. We're going to create a connection string for that database, and we're also going to then create the SQL data source. Now, the SQL data source is what does our actual SQL operation that we want to do on this page. You know, grab the faculty members, sort them this way, so on and so forth. The connection string will actually not get put in the SQL data source. It will actually get put in the web config file. All right? And that's good because we can then reuse that SQL connection string, every time we create a database connection within our application. So, let me show you what not to do. All right? New connection. Access database.